This is the timer lab, which is this is the one that's required. And we're using what we call a programmable timer, right? We've talked about this before. The programmable timer we're using is pretty straightforward. The one that you'll be doing when you take the sensors class is a little more complicated. And you'll have to look this up on the data sheet. So what do we mean by programmable timer? We talked about this the other day. So these are very popular in industry because you can have one timer that you can get several functions out of it. And I don't know if I can get this to focus in or not. I'm having problems with this camera focusing. And this is the only one I have. So this is a programmable counter. It's also called a contact control timer, excuse me. So what we have is they call it the input, but this is actually the power, and it's got a plus minus on it because this guy here will work on DC or AC. If you hook it up on AC, it makes no difference which one you hook up the plus and which one you hook up the minus. If you hook it up to DC, then you're going to have to honor this. Here's our contact. We got one single poke, single throw contact in this thing. Single poke, double throw contact. And you'll see that. We need to turn off a couple of sets of lights. Hold on a second. So we come up here, we press the start. M1 comes in. This is a magnetic motor starter. How do I know it's a magnetic motor starter? Yeah, got another load out there. That'll put power across the timer on what, pins 2 and 7. We got it set up to delay on make, so as soon as the timer is energized, this contact is closed, we jumped it out, so the timer will start timing. Once it times out, this normally closed contact will do what? It'll open, it'll cut off, so your motor should run for 10 seconds if you program it right. Everybody understand that? Yes or no? So we shouldn't have to use the control relay on this one. This is the second one if you get there. So that one is required. This is the second one. Oops, sorry. So here we're going to use a relay. So we're going to hit the start button, M1 will come in, it's going to fill in, so the light should come on. Now on this one, you're not going to hook up a motor because what happens is about what's the usual starting current, what's the rule of thumb starting current on a motor? 6 to 8 times. Well, these things are rated, I think, at like 1.8 amps. We've had this happen a couple of times where they hook up the motor and both their timer wasn't set up and both motors started at the same time. And guess what it did to those 10 amp fuses up there? Blew one, right? Because that thing's rated at 1 amp. We're trying to start 2, that's 16 amps, and it blew the fuse. So to prevent from blowing the fuse, if you don't set your timer up right, we're not going to hook up the motor on this one. We will hook up the motor starter. We just won't hook up the motor. Everybody understand that? So we hit the start. We got a contact down here because this is a contact control timer. So a voltage control timer, when you put power across it, it just times. On a contact control timer, a contact control means timer time. Everybody understand this? So what we're going to do on this one is we're going to set it up for delay on break. So I'm going to come over here, I'm going to hit my start button, M1's going to come in, a light's going to come on. This is, notice the arrow is pointing away from the switch, so this is the off delay timer, because we've got this thing programmed to be an off delay timer. Contact's going to do what? It's going to close instantly, because it's an off delay timer. The timing occurs on off. So you're going, okay, so this contact closed, but now we have it programmed to delay on break. So I hit the stop button over here. This contact breaks. Y'all understand that? The contact breaks. The timer starts timing. How can it time? Well, it's a solid state timer. It's across the power all the time, right? You understand that? Timer starts timing, and after 10 seconds, if it says 10 seconds, I can't remember, whatever it says, then the motor should stop. It starts getting pretty confusing because we're going to have to, now up here on this motor starter, when they wired it at EMC, they did something that's a little different. So technically, we've only got one auxiliary contact that we can use. Let's see if I can get the focus in. So the only auxiliary contact we have is two. One of them we couldn't use for the reverser because they got a connection between 3 and 10. This is wired on this motor starter. So that's why when we used the normally closed contact, we had to use this guy. I'm sorry, we had to use this guy right here when we do our reverser. That leaves us one normally closed here. It's between 5 and 6. And then we have this guy right here, but it's 3, but 3 is jumped to what? 10. Everybody okay? So that's why we couldn't use this contact right here on our motor, on our reverser, because we had to put a normally closed contact between 10 and the control, right? You understand that? But on this one, this motor starter right here, I'm using 10. Y'all understand that? I don't have to put this jumper right here. I don't have to put this jumper right here. Why? It's already there. So that means you don't have to hook. You can hook this to 10, and then you can put a jumper between 10 and the light and go it that way. And then this guy right here is made for you, right? You understand that? Yes or no? Okay. So this is going to work very similar, but we're adding 2 lights. And here we're going to use a delay on what? This is the contact control timer. This is on test, guys. The difference, the two categories of solid state timers is what? I'm sorry, programmable solid state timers. Is delay on make and delay on break. And this is the timer that you'll be using. Some of y'all will be using. So this is pretty simple. This one, you're going to have a book on this guy. Hopefully it'll focus in. So this one's got 3 controls on it. This is the one where you set what timer you want, and it's labeled OP, IN, ID, IOD, R, and R little b. And this is where you program what timer you want. So unless you're familiar with these, what you're going to have to do is find out, you're going to have to get the data sheet on this thing, right, to understand, and do what? Figure out what position to put that switch in. This is your multiplier. And then this right here would be your time. And this is a contact control timer. And to see where your simulated coil is, and to see where your contacts are, you're going to have to do what? You're going to have to look at the data sheet. So this one's a little different, but it's still just it's a programmable timer. So we can set it up on delay on, make, or we can set it up on delay on break. And we just have to figure out where that initiate contact is. Everybody understand that? Okay. So you're not going to use this in this semester. So that's if y'all get this far. You need to do the first one I showed y'all, which is not hard to hook up, right? You understand? And then this one if you get here. Another problem we have is the lab book. On some of the lab books, so I don't know what figure this is. See if y'all can find it in the lab book. So I'll give you this out too. We talked about this one, and this is why we can't use that 10 because we got this interlock circuit in here, right? So this is figure. I got it figure. Let me look at my thing. CR 715 is what I have in the lab book. And the problem we have here, so this is a replacement. So there's so many corrections on these. I'll give you out the replacement figure, right? You understand that because it's just too many to document inside my lab book. This one, of course, we're using 2 motor starters, so we don't have that shared interlock. We're simulating a reversing controller. I think what they have is they have these start and stop buttons reversed. I think they have it already open on the stop button side. I mean, on this guy. And then they have a normal close there, if I remember right, with the arrow there. So what does y'all book say? Can y'all find it? Well, when you get to the lab, so this guy is using a common stop. And of course, when I press the forward without hitting the stop, it's going in what we call reverse. And if we press the forward without hitting the stop, you're going to plug the motor. Right? You understand that? So we don't like plugging motors. It's not going to hurt ours, even though ours has a service factor of 1. It's not under load. Also, it's trying to reverse it. It's just the force of the road. Load, you could hurt the motor, right? Or keep it overload. Hopefully, the overload is precise, right? And what happens a lot of moters is overload is right, and you plug them more than it is. Your overload. So if you do this stuff, what you need to do between hitting forward and reverse, you need to hit the watch stop button. And these are our push buttons. So we have this on the push button station that's got 3 push buttons. We got a stop button on there. It's one normally closed. And then we've got 2 interlocked double pole single throw, I think. That we can wire to either was. Normally open is the normally closed. But notice up here the reverse. You got 2 sets of lights up here. That was being used. This is the start-stop station you'll be using for this circuit. and they got the legend plate forward and reverse. But these are double pole single throws, right? You understand that? And then you've got what over here on the right, you got to stop. So you can wire this whole circuit as far as your stop station as you can use this one thing right here. So over here on the reverse, this guy right here would be 5 and 6, and then down here, this right here would be 7 and 8 off of the off the reverse switch. And what people want to do, of course, is put these together, right? You understand that? But this, so what happens after the motor stops, if I come over and hit start forward, it will automatically break the reverse, right? And if I hit reverse, it'll automatically break the start. You understand that? Okay. So this could definitely be plugged real easy if you don't do what between each one of them. Stop it, yeah. But there's no way in the world we could energize. So here we're doubling up on our interlocks. So we're also, yeah, they're mechanically connected together or operated by the same operator. So we got mechanical interlocks over here on the left, and then we got electrical interlocks. So you can energize these at the same time. You got it totally wired wrong, right? So guys, that's the two circuits. We have one reverser that everybody's got. Hopefully, that's one of our SLOs. You have to do that. And then I want you to do at least one timer lab. We're going to use the programmable timer, and it's going to act just like an on delay. So all you got to do is just jump that 5 and 6, and it would act just like a normal solid state on delay timer. But we have a contact, it's a contact control timer. And what does that mean? So what's the bit of voltage control timer? Contact control timer is on the table. Voltage control timer has no issue. Time is started when we power it up. There's no system they programmable off the way. Solid state timer. Come on, because that was kind of so the timer we can have a solid state off play timer. We can have voltage control timer, excuse me. Of course, pneumatic timers or dashpot timers or these other timers, they don't care. Everybody okay on these? Any questions on these?